Okay, so my name's Madeleine Dupont and I'm an Associate Research Fellow at Deakin University with the Institute for Frontier Materials. My research project, I'm focusing on thermocells. So these are basically energy generation devices that convert heat into electricity. So we're looking at using these to harvest waste heat. So from either the human body, from vehicles, from industrial processes, we can convert this heat that's produced into an electricity source. So yeah, it's a pretty exciting area. It's important because we rely a lot on energy in the form of electricity, and at the moment we source a lot of our energy from fossil fuels and non-renewable resources. So obviously there's a big move to move into things like renewable energy, but also energy storage. But a big part of transitioning away from fossil fuels is improving sort of fuel efficiency and energy efficiency. So if we can harvest energy from a source that's readily available and it's free, it's being produced anyway, we can harvest this heat energy that's going to waste and use it to power devices, maybe feed it back into the process that it's being generated from. So yeah, sort of improving energy efficiency sort of across the board. I guess we start off very fundamentally, like we consider the sort of materials and like chemicals and things that we'll use to build these devices, and we study them at a very fundamental level. So very lab-based. We will like heat up our materials and we see the sort of power that we can generate from them, and then we'll start to build them up more into a device style sort of setup where it will more replicate how you'd use them in an actual application. And then we start to optimize the properties, whether that's changing electrode properties, changing electrolyte properties. We see the sort of design features we can introduce to improve our output and power and current generation. So yeah, so we start very fundamentally and sort of build it up to optimizing it. In terms of the methodology, I think a lot of what we do is very fundamental, actually. Like, it seems like from today's exercise that some of the very fundamental studies we do are kind of quite relevant at a basic level to what school kids can do. Like, it's all very basic sort of stuff. So it's really important for them to just understand like how science happens, and you can just measure, measure responses, measure like experimental procedures and stuff. So yeah, I think it's important for school kids that they can have a go at that. We're trying to tie this in. There's a few different areas that we're looking at. We're looking at like temperature dependence of chemical reactions. We know that under different temperature conditions, reactions happen differently. They might have produced more of one product or less of the other. So we utilize that, but we're also looking at oxidation and reduction reactions. So basically a transfer of electrons from one species to another, and then all over how we can put those two things together to make basically a circuit. So we can run electrical current through a circuit. So it's kind of a bit of brings in and ties in a whole different areas. So kind of, covering redox chemistry, thermal dependence, but also electrical circuits and current flow. So I think it's really good because I think the sort of research that we do is so removed often from what you learn in high school. And as a high school student, sometimes you wonder how any of what you're learning can actually be used in an application. So it's quite good if you can take a very fundamental aspect of like what we do as researchers and teach it to students who can then see how with a bit of development and a bit more, they could potentially see this being a technology or being an application that they might actually use in their everyday life.